Long before the first cities were built, ancient people were mapping the stars with stunning accuracy. We are traveling back to the world's oldest observatory, a discovery that rewrites the very origins of science and society. You will learn how the celestial knowledge of our ancestors laid the groundwork for everything from farming to monumental architecture, proving they were master astronomers, not primitive mystics. How did a structure older than the wheel function as a precise observatory? And what forgotten secrets about time itself did these first stargazers encode in stone? What does our own place in the universe owe to those first, curious looks toward the heavens? So forget the modern image of a telescope under a dome. The true essence of an observatory is alignment. It is a device designed to capture a specific moment in the cosmic cycle, a calendar built not of paper but of stone and shadow. For the ancients, the most critical events were the solstices and equinoxes. These were not abstract astronomical terms, but the fundamental pillars of their existence. The winter solstice marked the sun's rebirth, the promise that the bitter cold would eventually retreat. The summer solstice brought the peak of the sun's power, vital for growing crops. The equinoxes, when day and night stood in perfect balance, were moments of profound harmony. To predict these events was to hold power over time itself. It meant knowing precisely when to plant, when to harvest, when to conduct sacred ceremonies to ensure the sun would continue its journey. This was the urgent, practical need that drove the creation of the first observatories. They were not built for idle curiosity, but for survival. The genius of these early astronomers was in turning the entire landscape into their instrument. A single standing stone, positioned just so, could catch the first ray of the rising sun on the longest day of the year, illuminating a sacred chamber or casting a long, dramatic shadow across a designated marker. A pyramid's sides could be aligned with the cardinal directions with breathtaking precision, anchoring their entire world to the unshakable order of the cosmos. This was a science born from the earth, watching the sky, and it is this foundational principle that leads us to a windswept plateau in modern-day Germany, to a place that shattered our understanding of when humanity first began this practice. This windswept plateau in Germany is not the only place challenging our timelines. Far to the southeast, in the rolling hills of modern Turkey, lies a discovery so profound it forces us to rewrite the prehistory of astronomy. This is Göbekli Tepe, built a staggering 11,500 years ago. This complex is older than Stonehenge by over 6,000 years. That is a span of time longer than the entire recorded history of human civilization. For decades, archaeologists interpreted the site as a purely ritualistic temple, a sacred gathering place for hunter-gatherers. Its massive T-shaped limestone pillars, some weighing over 10 tons, were arranged in great stone circles and covered with elaborate carvings of animals. It was seen as a place of ceremony, of myth. But what if the myth was written in the stars? Recent analysis suggests these pillars were not placed at random. Their arrangement appears to be a sophisticated code. Specific pillars and the creatures carved upon them seem to align with the rising of certain stars, most notably Sirius, the brightest star in our night sky. Other alignments may have marked the solstices, turning the entire complex into a giant stone calendar. This implies something revolutionary. The world's oldest known megalithic structure might also be the world's oldest observatory. Think about what this means. The people who built Göbekli Tepe were not farmers living in settled villages. They were hunter-gatherers, people we have long imagined as living a hand-to-mouth existence, constantly on the move. Yet here they are, erecting a monumental complex that required a huge, coordinated labor force and, crucially, a deep understanding of celestial cycles. They were not just building for the Earth but for the sky. They were tracking time itself, using the stars to predict the changing seasons, the migrations of animals, and the rhythms of the natural world upon which their survival depended. This celestial knowledge was not a luxury. It was the very foundation that may have made settled life possible. How did observing the stars lead to the first permanent communities? The secret might be buried not in the stones but in what they were watching for. The sheer scale of Göbekli Tepe forces us to ask what these pillars were truly for. Enclosure D, one of the most complete and imposing circles, offers a compelling clue. Its central pillars are not arranged randomly. Researchers, including Giulio Magli, have proposed a stunning alignment. They suggest the two central monoliths point directly toward the constellation of Cygnus, the Swan, as it rose in the northern sky 11,000 years ago. This is not a vague connection. It is a precise, engineered sightline frozen in stone, but the astronomical code does not end there. Look closely at the pillars themselves. They are covered in a menagerie of carved creatures, from scorpions and foxes to birds and vultures. For a long time, these were seen as symbols of a primitive belief system, spirit animals of a forgotten religion. Yet what if we have been misreading them? What if these carvings are not just mythical symbols, but a literal map of the night sky? The scorpion might represent the constellation we still call Scorpius today. The fox could be a depiction of a different star pattern, its meaning lost to time. This would make the entire enclosure a zodiac carved in limestone, a storybook of the heavens where every animal marked a celestial territory. To achieve this, the builders displayed a frighteningly advanced intellect, positioning these multi-ton pillars to create perfect sightlines for specific stars or the solstice sun required more than brute force. It demanded a deep understanding of geometry, of angles, and of the slow, predictable dance of the cosmos. They were not simply marking where a star was, but where it would be year after year for generations. This was not casual stargazing. It was a coordinated, communal project on a monumental scale, a permanent calendar built to last for ages. The implication is staggering. A sophisticated society with specialized knowledge, architects of both stone and time, was already flourishing long before the first seeds of what we call agriculture were ever sown. The immense labor at Göbekli Tepe only makes sense if the stakes were unimaginably high. For a society living directly from the land, the sky was not a subject for abstract study. It was a practical tool for survival. The precise return of the seasons dictated everything. A miscalculation could mean missing the migration of a herd you depended on for food, or failing to anticipate the arrival of autumn rains. These were not inconveniences, they were existential threats. So when a star like Sirius first appeared in the pre-dawn sky, an event known as its heliacal rising, it was not just a beautiful sight. It was a signal. In ancient Egypt, this same event heralded the life-giving flood of the Nile. For the people of Göbekli Tepe, it might have signaled the movement of gazelle, the ripening of wild grains, or the onset of a critical weather pattern. The stone pillars were their way of locking in these celestial warnings, creating a permanent, reliable calendar that everyone could follow. This transforms our understanding of the site. Göbekli Tepe was likely more than a temple. It was a central repository of essential knowledge. The keepers of this calendar, the individuals who understood the alignments, held the power to direct the community, to say, the solstice is near, prepare for the gathering, or Sirius will rise tomorrow, the time to move to the summer grounds has come. This was the institutionalization of time itself, a communal project that turned the unpredictable chaos of nature into a scheduled, manageable world. But if this knowledge was so powerful, why was this revolutionary site and all its celestial wisdom deliberately and carefully buried? The deliberate burial of Göbekli Tepe is one of archaeology's great mysteries, but its timing offers an even more profound puzzle. This monumental complex was built and used right at the very edge of the Neolithic revolution, that pivotal moment when humanity shifted from a life of nomadic hunting to settled farming. For generations, we were taught a simple story. First, humans discovered agriculture, which provided a stable food surplus. This surplus then allowed for the growth of villages, then towns, and finally the spare time and resources needed to develop complex society, religion, and science. Göbekli Tepe turns this entire timeline on its head. Here we have clear evidence of a complex, coordinated society capable of erecting colossal stone structures, all before any evidence of farming in the region. So what came first? The traditional story insists on the farmer, then the temple, but the stones themselves whisper a different truth. They suggest the temple came first and the farmer followed. How could that be possible? The answer lies in the sheer number of people required. Building and maintaining a site of this scale would have demanded a large, semi-permanent workforce, hundreds of people who needed to be fed. You cannot feed a small army of laborers with the sporadic luck of the hunt alone. This pressing, practical need may have been the very catalyst for one of humanity's most transformative inventions. The gatherers who knew where wild grains grew would have been pressured to find ways to produce more, right here, leading to the first deliberate cultivation of plants. The hunters who drove gazelle would have started to corral and manage them, beginning the long process of domestication. In this revolutionary light, astronomy was not a leisurely hobby that emerged after civilization was secure. It was the engine that drove civilization itself, the shared spiritual and astronomical worldview that brought people together to build this stone calendar, created the social organization, and the urgent necessity that made farming not just possible, but imperative. The stars did not just guide them, they may have commanded them to plant the very seeds of our modern world. This celestial knowledge was a torch passed through the ages. The profound discoveries made at places like Göbekli Tepe did not simply fade into the dust. They were the original seed, the foundational blueprint from which every major civilization that followed would build its own understanding of the cosmos. The core principles were universal: track the cycles, mark the time, build in harmony with the heavens. This was not a series of independent inventions, but a slow, cumulative process of knowledge being passed down, adapted, and refined over thousands of years. The farmers of ancient Egypt aligning their pyramids with the pole star, the builders of Stonehenge capturing the solstice sun, the Maya priests calculating the orbit of Venus with breathtaking accuracy, all were working from the same fundamental playbook written by those first pioneers. They were the ones who first mapped the great clockwork of the heavens. They gave humanity its first true framework of measured time, a stable, predictable structure against which societies could plan their harvests, coordinate their rituals, and ultimately grow in complexity and power. We still live within the legacy of their vision. Every time you glance at a calendar to mark a date or plan a project for the coming season, you are using a conceptual tool first forged not in a modern laboratory, but in the minds of ancient stargazers standing before colossal stones. Their greatest gift was not a list of star positions, but the very idea that time itself could be measured, understood, and relied upon. This revolutionary concept raises a final, haunting question. If these first astronomers were so advanced, capable of such profound intellectual leaps, what other secrets did they uncover about our universe that we have only just begun to rediscover? This long-term dedication to the stars found its ultimate expression along the fertile banks of the Nile. In ancient Egypt, the sky was not an abstract wonder. It was a direct command from the gods, and its primary interpreter was the river itself. The entire civilization was a gift of the Nile's annual flood, a surge of water and rich, black silt that transformed the desert into a lush, green paradise. But this gift was also a potential catastrophe. If the flood arrived too early, it could wash away young crops. If it came too late, the fields would bake dry under the sun. The survival of millions depended on predicting this event with absolute accuracy, and the Egyptians discovered their most reliable signal not on Earth, but in the pre-dawn sky. They watched for the heliacal rising of the star Sirius, which they called Sopdet. This was the moment, after a period of invisibility, when Sirius first reappeared just above the horizon moments before sunrise. For them, this was not just a star. Sopdet was a goddess, and her return was a divine announcement. Her brilliant gleam in the morning twilight signaled that the Nile's life-giving waters were on their way, marking the Egyptian New Year and the beginning of the season of inundation. This celestial warning gave farmers precious days to prepare their fields and their communities for the coming deluge. The Egyptian priests, the scholars of their age, became the masters of this celestial clock. Their observations were so meticulous that they developed one of the first known solar calendars, a year of 365 days. This was a monumental achievement in practical timekeeping, a framework that organized their entire society around the rhythm of the star and the river. But their understanding went far deeper than a simple annual cycle. Over centuries of patient observation, they detected a slow, majestic wobble in the Earth's rotation, a phenomenon we now call the precession of the equinoxes. This cycle, which takes 26,000 years to complete, shifts the entire celestial backdrop against which the stars rise and set. The Egyptian recognition of this grand, multi-millennial rhythm reveals a truly staggering depth of knowledge. It shows they were not just predicting the next flood, but were mapping the cosmos across timescales almost impossible to comprehend, viewing their place within a divine order that stretched far beyond a single human lifetime. Their astronomy was a seamless fusion of the practical and the theological, a science dedicated to survival, rooted in a profound belief that the workings of the universe and the fate of their civilization were one and the same. This ambition to fuse earth and sky reached its zenith with the pyramids. These structures were far more than royal tombs. They were the ultimate precision instruments of a solar cult, designed to physically launch a pharaoh's soul into the cosmic realm. The Great Pyramid of Giza stands as the supreme example, a monument to an almost supernatural understanding of mathematics and the heavens. Its four sides are not merely roughly oriented. They are aligned to the four cardinal directions, north, south, east, and west, with an error of less than 1/15 of a single degree. To achieve this on such a colossal scale, with blocks of stone weighing multiple tons, required more than simple guesswork. It demanded a level of geodetic skill, of land surveying and measurement that seems to defy its age. But the alignments reach beyond the horizon and into the stars themselves. Deep within the pyramid, narrow shafts, often called air shafts, extend from the central king's chamber. For a long time, their purpose was a mystery. We now understand they were not for ventilation, but for stargazing. One of these shafts points directly north toward the circumpolar stars, the stars that never set in the night sky. For the Egyptians, these eternal, undying stars were the realm of immortality. Another shaft points precisely south toward the three stars of Orion's belt. This constellation was intimately linked to Osiris, the god of death, resurrection, and the afterlife. So what was the pyramid's true function? It was a celestial launch pad. The entire structure was a machine designed to channel the king's spirit, his ka, directly from his entombed body, up through these star-aligned shafts to take its place among the imperishable stars for all eternity. This was the physical manifestation of Maat, the cosmic order, a perfect alignment of the mortal world with the divine and unchanging heavens. The pyramid was not a grave marking an end, but a gateway for a journey that never truly ended. Meanwhile, far to the east of the Nile, a completely different philosophy of the stars was taking root. In the fertile crescent between the Tigris and Euphrates rivers, the Mesopotamian sky was not a predictable clockwork of cycles, but a living, breathing script. The gods did not simply run the universe, they actively communicated through it. Every flicker of a planet, every darkening of the moon during an eclipse, was a direct and urgent message concerning the fate of the king, the health of the harvest, and the future of the entire kingdom. This was not astronomy for calendar keeping, it was celestial diplomacy, a desperate attempt to read the minds of unpredictable deities. To interpret these divine signs, a powerful class of scholar scribes emerged in Babylon. From around the 2nd millennium BC, these individuals dedicated their lives to the night sky, creating an unparalleled archive of observation. They did not write on papyrus, but pressed their findings into soft clay tablets, thousands of which have survived, giving us a direct window into their minds. Their work was not casual. They meticulously tracked the slow, wandering paths of the planets against the fixed backdrop of stars. They recorded the terrifying moments when the moon turned the color of blood and the sun vanished from the sky. This was not done out of pure scientific curiosity, but from a profound belief that these events were omens. A lunar eclipse might foretell the death of a king. The appearance of Venus in a certain part of the sky could signal an impending war. The scribes were the cryptographers of the cosmos, tasked with decoding these celestial warnings to advise their rulers. Yet, in their search for divine patterns, they stumbled upon something revolutionary. By compiling these records over centuries, they began to see that the chaos was not random. The gods, it seemed, followed rules. Their most stunning discovery was the Saros cycle. They realized that solar and lunar eclipses repeat in a pattern of roughly 18 years. Imagine the intellectual leap this required. To see past the fear and the mythology, to sift through generations of data and find a predictable, mathematical rhythm in the most dramatic celestial events. This was the moment astrology began its slow transformation into astronomy. They did not stop there. Their relentless tracking of the planets led them to develop the first complex mathematical models to predict their motions. They created the zodiac, dividing the sky into 12 sections to map the sun's annual path, a system we still use today. In their quest to understand the will of the gods, the Babylonian scribes laid the essential groundwork for the entire scientific study of the heavens, proving that even a search for divine meaning could reveal the profound, underlying mathematics of our universe. This search for cosmic order was not confined to grand empires. In the forests of Bronze Age Europe, another masterpiece of celestial engineering was being forged, not from stone but from metal. The Nebra sky disk, unearthed in Germany in 1999, is a breathtaking artifact that shatters our assumptions about prehistoric Europe. Crafted around 1600 BC, this small bronze disk, inlaid with shimmering gold symbols, is the oldest known physical map of the sky ever discovered. It is not a vague pattern. Its gold appliques clearly depict a cluster of 7 stars, almost certainly the Pleiades, a crescent moon, and what is likely a full sun or full moon. But this was far more than a simple picture. The disk was a sophisticated astronomical computer. 2 golden arcs along its edges, added later, represent the precise range of the sun's movement between the summer and winter solstices. Another arc at the bottom, often called the solar bark, may symbolize the mythical ship that carried the sun through the night. When used in conjunction with the horizon, the disk could calculate the exact point in the year when a 13th lunar month needed to be inserted to keep the shorter lunar calendar in sync with the longer solar year. This correction, known as an intercalary month, was vital. Without it, the lunar months would slowly drift through the seasons, causing festivals and planting times to fall in the wrong season. The disk's existence tells a revolutionary story. It proves that the deep astronomical knowledge needed to manage agriculture was not a secret held only by Egyptian priests or Babylonian scribes. Here, in the heart of ancient Europe, a society we once called barbaric possessed the same complex understanding of time and the cosmos. They too were master calibrators, synchronizing their world with the grand, silent metronome of the heavens. Yet the ambition to build a working model of the cosmos was not unique to the continent. Across the Channel, on the Salisbury Plain in England, a society raised a monument that would become the very symbol of ancient astronomy, Stonehenge. Constructed in phases over a millennium, beginning around 3000 BCE, this ring of towering Sarsen stones represents a pinnacle of megalithic engineering and celestial understanding. Everyone knows its iconic silhouette, but few grasp its true function. The central axis is famously aligned to the summer solstice sunrise, a fact that draws thousands of visitors every year. But to see only a solstice marker is to miss the monument's staggering genius. Stonehenge was a Neolithic computer, a machine of stone and shadow designed to calculate the complex rhythms of the sun and the moon. The key to its operation lies in the architecture. The massive outer circle of Sarsen stones capped with lintels creates a continuous ring. Within this, the smaller blue stones were arranged and rearranged in specific patterns. Researchers like Gerald Hawkins proposed that these 56 Aubrey holes, the pits that circle the monument, were used as a primitive counting system. By moving markers from hole to hole each year, priests could track the much longer 18.6-year cycle of the moon. Why was this lunar cycle so important? Because understanding this rhythm was the key to predicting eclipses, the most dramatic and terrifying celestial events known to the ancient world. A lunar eclipse when the Earth's shadow consumes the full moon, or a solar eclipse when the sun is blotted out in the middle of the day, were moments of profound spiritual significance. They were seen as battles between light and dark, order and chaos. The ability to predict such an event was the ultimate demonstration of power, a way to show command over the very heavens. This was not a simple calendar. It was a device that integrated the solar year, which governs the seasons, with the more complicated lunar cycles. It allowed its keepers to announce not just the time to plant or harvest, but to prepare the people for the awe-inspiring moment when the predictable sky seemed to break its own rules. Stonehenge stands as a testament to a society that saw no separation between the earth and the sky, a culture that built a computer from stone to synchronize their lives with the grand, silent music of the universe. The same profound connection between stone and sunlight was being forged on the misty hills of Ireland. Newgrange is a massive, circular mound older than both Stonehenge and the Great Pyramid of Giza. Built over 5,000 years ago, its white quartz facade would have glittered in the landscape, a man-made hill holding a deep secret. The true genius of the structure lies not in its exterior, but in a single, slender opening carefully positioned above the main entrance, a feature known as the roof box. This was not a doorway for people, but a channel for light. For the entire year, the interior of the tomb remains in profound darkness, but for a few precious days around the winter solstice, something miraculous occurs. As the sun crests the horizon on the shortest, darkest day of the year, a narrow beam of light pierces through this roof box, it does not simply flood the chamber. It travels with purpose down a long 19-meter passageway, a corridor that narrows like the barrel of a telescope until it reaches the very heart of the tomb. There, in the central chamber, it illuminates intricate spiral carvings on the back wall for a brief 17-minute performance. This was not a happy accident. The entire structure was engineered with breathtaking precision, the passage and roof box angled to capture only this specific sunrise on these most critical days of the year. The effect would have been overwhelming for the small group of people gathered inside. After the long descent into winter, the gradual weakening of the sun, here was undeniable proof of its return. The creeping beam of light in that sacred space was the ultimate symbol of rebirth, a divine promise that the cold would end and the fields would grow again. This was more than architecture or astronomy. It was a spiritual machine, a ritual engineered into stone, designed to deliver hope itself in a single, golden shaft of light. This democratic approach to timekeeping reveals a profound shift in how ancient societies related to the sky. While the pyramids of Egypt served a pharaoh's journey to the stars and Stonehenge may have been a sacred site for a powerful priesthood, Chankillo feels different. Its design is brilliantly public. The two observation points carefully positioned on either side of the hill are unadorned, simple structures. There are no grand chambers, no hidden shafts reserved for an elite few. Anyone standing at the western observation post could watch the sun set behind the specific tower that marked the June solstice. From the eastern point, the entire community could witness the December solstice sunrise aligned with the opposite end of the row. The entire year was laid out before them, a celestial calendar etched across the horizon, its code available to all who knew how to look. This suggests a society where the knowledge of the seasons, the timing of planting and harvest, of religious festivals and community gatherings was a shared resource. It was a solar clock for the people, its accuracy built not into a portable disk or a complex stone computer, but into the very shape of the land itself. The 13 towers stand as silent witnesses to a collective understanding of the cosmos, a testament to the idea that the sun's journey was a rhythm for everyone to follow, not a secret for a chosen few to interpret. The Maya looked up and saw a sky governed by mathematics. Their entire civilization was built upon a foundation of celestial observation, so precise it rivals our modern calculations. For them, the sun was not a distant ball of fire, but a divine being whose most intimate moments could be measured with stunning accuracy. One of their most critical observations was the Zenith passage. In the tropical latitudes where their cities thrived, the sun passes directly overhead at noon on 2 specific days each year. On these days, vertical objects cast no shadow at all. The world was plunged into a moment of profound stillness, a direct vertical connection between the heavens and the earth. These were not abstract astronomical events. They bracketed the coming of the torrential rains, the signal to prepare the fields for planting maize, the sacred crop that sustained their world. The Zenith passage was a divine alarm clock, and the Maya built their cities to be its echo. At Capon, a grand stairway inscribed with hieroglyphs may have been aligned to mark this very event, turning the entire city into a timekeeping instrument. This obsession with precision reached its ultimate expression in their calendars. You have likely heard of the long count, the system that fueled modern myths about the world ending in 2012. In reality, it was nothing so apocalyptic. It was a magnificent linear count of days from a mythical starting point, a way to place their kings and their history within a vast cosmic timeline. Think of it as a cosmic odometer relentlessly ticking forward. But the true genius of the Maya was their ability to weave multiple cycles together. They calculated the solar year to be more accurate than the calendar used in Europe at the very same time. They tracked the 584-day cycle of Venus with such precision that they could predict its appearances as both the morning and evening star. They even mastered the complex rhythm of eclipses, seeing the patterns in what must have seemed like celestial chaos. For the Maya, time was not a simple, linear progression. It was a sacred, layered entity, a complex machinery of interlocking gears spun by the gods. Their calendars were not just for counting days, they were a philosophical statement, a belief that the universe itself ran on a predictable, mathematical order that the human mind could not only observe but truly comprehend. This Greek transformation began not in a temple but in the marketplace of ideas. While the Babylonians saw omens and the Egyptians saw divine commands, a new breed of thinkers on the shores of Ionia asked a radical question. What if the cosmos operated not on the whims of gods but on consistent, knowable laws? Thales of Miletus, often called the first Western philosopher, embodied this shift. He reportedly predicted a solar eclipse in 585 BCE, an event that allegedly stopped a battle. Whether the story is true or not, its significance is profound. It suggests a man using knowledge, not divine inspiration, to foresee a celestial phenomenon that others saw as a terrifying omen. This was the birth of a new idea, that the universe was predictable. This intellectual audacity only grew. A century and a half later, Aristarchus of Samos looked at the same sky and proposed something that seemed utterly insane. He suggested that the Earth was not the center of all things, but that it, along with the other planets, revolved around the Sun. He even estimated the relative sizes and distances of the Sun and Moon with a geometric brilliance that was centuries ahead of its time. His heliocentric model was the correct one, a stunning leap of logic and imagination. Yet his idea was largely rejected. Why? Because it challenged not only common sense, but the entire philosophical and aesthetic order of the universe. If the Earth moved, where was the great wind? Why did the stars not appear to shift their positions? The elegant, Earth-centered cosmos felt more right. And so it was the work of Claudius Ptolemy, writing in the 2nd century CE, that came to define astronomy for the next 1400 years. Ptolemy's geocentric model was a masterpiece of mathematical complexity, designed to save the appearances of the planets. To explain why Mars, Jupiter, and Saturn sometimes appear to loop backward in the sky, a phenomenon called retrograde motion, he devised a system of epicycles. Imagine a planet moving in a small circle called an epicycle, whose center itself moves along a larger circle around the Earth called a deferent. This cosmic gear work, with planets whirling on their own little circles while journeying around the Earth, could accurately predict planetary positions. It was a brilliant, if convoluted, solution. The Greek synthesis was now complete. They had taken the raw data of the Babylonians and the cyclical patterns of the Egyptians and forged something entirely new, a cosmos governed by geometry. The heavens were no longer a scroll of divine messages, but a physical mechanism to be analyzed. This shift from myth to mathematics, from reading omens to modeling orbits, was their ultimate gift. It established the fundamental principle that the universe is rational and that its secrets can be unlocked not by priests, but by anyone armed with reason and observation. This intellectual foundation would lie dormant for centuries, a seed waiting for the right conditions to sprout into the scientific revolution. Yet across the vast emptiness of the Pacific Ocean, an entirely different kind of celestial science was being perfected, one that needed no stone circles or towering pyramids. The Polynesian voyagers embarked on journeys of staggering ambition, navigating thousands of miles of open ocean to settle the most remote islands on Earth. They did this not with sextants or charts, but with a mental map of the heavens so precise it functioned as a living compass. This was the star path. Master navigators, known as wayfinders, committed the night sky to memory. They knew hundreds of stars, not just as individual points of light, but by their precise rising and setting positions on the horizon. A star was not a static object, it was a destination. To sail toward the east, you would follow a star that rose in the east. As that star climbed too high, you would simply transfer your alignment to the next star rising from the same point on the sea's edge. The entire celestial dome was a great wheel, and by locking onto these specific spokes, a wayfinder could hold a true course for weeks on end. But their astronomy was not confined to the night. They were holistic scientists of the natural world. They read the subtle patterns of ocean swells, feeling how they deflected around islands far beyond the horizon. They watched the specific flight paths of seabirds at dusk, knowing they would lead toward land. They interpreted the color and shape of clouds, which often gathered over unseen lagoons. All of these clues were woven together, with the stars providing the unwavering, constant thread. This knowledge was their most sacred treasure, passed orally from one generation to the next through chance and intense apprenticeships. It was a dynamic, fluid observatory carried not in stone, but in the human mind, enabling one of the most breathtaking chapters of human exploration. How many other sophisticated sciences, equally profound, have been lost to us because they were built from memory and song instead of clay and granite? While the Greeks were building their geometric models, a parallel revolution was unfolding in the Indian subcontinent. A series of profound texts known as the Siddhantas, composed between the 1st and 5th centuries CE, elevated astronomy into a precise mathematical science. These were not vague philosophical treatises, but practical manuals filled with algorithms, rules for calculating the positions of planets, predicting eclipses, and mapping the very structure of the cosmos. The most celebrated of these, the Surya Siddhanta, or the knowledge of the sun, reveals a staggering level of insight. It contains remarkably accurate estimates for the diameters of the planets and their distances from Earth, calculations that required a deep understanding of geometry and scale. These astronomers did not see a flat world beneath a dome. They understood our planet to be a sphere, a bugola, and they calculated its circumference with a precision that would not be rivaled in the West for centuries. How did they achieve this without telescopes or modern instruments? Their tools were abstraction and relentless logic, yet this was not a purely secular pursuit. The entire framework was deeply interwoven with Vedic cosmology and the critical need for precise timekeeping for religious rituals. The timing of a sacrifice had to be perfect, aligned with specific celestial configurations to be effective. This spiritual necessity drove them to observe the heavens with an unmatched intensity, transforming their rituals into a rigorous science. Their mathematical astronomy became a sacred act, a way of decoding the divine order written in the motion of the planets. This fusion of the spiritual and the scientific produced a body of knowledge so powerful it would flow along trade routes, influencing astronomical thought from the Islamic world to the far reaches of Southeast Asia, proving that the quest to measure the heavens was a truly universal human endeavor. While the Greeks philosophized and the Polynesians sailed, an entire civilization was building a celestial archive of staggering longevity. In ancient China, the sky was the ultimate report card for the emperor himself. His right to rule, known as the Mandate of Heaven, was not a permanent grant of power. It was a contract, a divine approval that could be revoked at any moment by the cosmos itself. A sudden eclipse, a strange new star blazing in the night, or the ominous sweep of a comet's tail were not mere astronomical events. They were direct messages from the heavens, a celestial review of the emperor's virtue and his administration's competence. A mismanaged eclipse could be interpreted as a sign that the ruler had lost the favor of the gods, potentially sparking rebellion or dynastic collapse. This high-stakes pressure created a powerful, state-sponsored motivation for observation. The role of the court astronomer was not just a scientific post, it was a matter of national security. These scholar officials were tasked with an immense responsibility to watch the sky every single night for any sign of divine displeasure and to keep a perfect, unbroken record of everything they saw. For over 2,000 years, through the rise and fall of countless dynasties, the observatories of China maintained this vigil. Their meticulous logs became the longest continuous astronomical record in human history. This was not a pursuit of abstract knowledge, but a desperate, systematic effort to read the mind of heaven and preserve the social order. The sheer volume of data they compiled is almost unimaginable. They noted every eclipse, every planetary conjunction, and every guest star, which is what they called the sudden appearance of a supernova. One of their most famous entries describes the supernova that created the Crab Nebula in the year 1054. They wrote of a guest star visible in the daytime for 23 days, a brilliant new point of light in the constellation Taurus. This single entry, buried in their imperial archives, has allowed modern astronomers to precisely date the origin of one of the most studied objects in the sky. To make these precise observations, Chinese astronomers engineered some of the most sophisticated instruments of the ancient world. They perfected the armillary sphere, a complex bronze model of the celestial sphere with interlocking rings representing the equator, the ecliptic, and other key coordinates. By aligning these rings with the sky, they could pinpoint the location of any star or planet with remarkable accuracy. Their relentless gaze even led them to a discovery that would not be named in the West for another 1,000 years. They carefully documented that the tails of comets always streamed away from the sun, regardless of the comet's direction of travel. They were, in effect, observing the solar wind, the constant stream of charged particles flowing from the sun that pushes cometary material into that iconic glowing tail. They saw the pattern even if they did not understand the underlying physics. This bureaucratic, systematic approach to the cosmos, driven by the need to legitimize political power, created an unparalleled gift for the future. It is a haunting thought that the fate of empires written in starlight and shadow would one day become the foundational data for a science they could never have imagined. This convergence of celestial ideas across the globe is no mere coincidence. From the deserts of Egypt to the highlands of Peru, from the Babylonian plains to the Chinese river valleys, we see the same fundamental patterns emerge time and again. The most obvious is the solar calendar. Civilizations with no possible contact with one another, each independently converged on a year of 365 days, a number that is not perfectly precise but represents a powerful, shared human estimation of the sun's cycle. And each of them, from the Romans to the Maya, recognized the same problem. The solar year is not a neat, whole number of days. To keep their calendars from slowly drifting into seasonal chaos, they all invented the same solution: the intercalary day or month. A periodic correction slipped into the calendar to reset the clock. This was not copied knowledge, it was a universal response to a universal observation. The same celestial events held power for everyone. The solstices, those moments of the sun's extreme reach, and the equinoxes, the perfect balance of light and dark, were universally marked with stone, ceremony, and precise alignment. Think of Newgrange capturing the winter solstice sunrise, or Chankillo's towers framing the sun's entire yearly journey. These were not local quirks of belief, but global recognitions of the sun's fundamental rhythm. Look up at the night sky, and one tiny, sparkling cluster seems to have captivated humanity more than any other. The Pleiades, a faint smudge of 6 or 7 stars, appears in the myth and practical astronomy of cultures from ancient Japan to the indigenous peoples of North America. For the Greeks, it was the 7 sisters. For the Maori of New Zealand, it was Matariki, a signal for the new year. For many early farmers, its heliacal rising, its first appearance in the dawn sky, was the long-awaited signal to begin planting. This was not because the stars magically affected the soil, but because their appearance was a perfectly reliable, celestial alarm clock marking a specific point in the seasonal cycle. And then there is Orion. The same hourglass figure of bright stars was seen by the Egyptians as the god Osiris. The Mesopotamians saw a heavenly shepherd. The Maya saw a celestial turtle, and some Aboriginal Australian groups saw a group of young men dancing. The constellation was the same, but the story projected upon it was a reflection of each culture's unique world. This reveals something profound about our ancient ancestors and about ourselves. The human brain, when presented with the same starry canvas, the same sun, and the same moon, seems wired to identify the same practical patterns. The drive to track time for agriculture, to mark the seasons for ritual, and to find meaning in the chaos of the night sky created a shared cognitive framework. It was a universal language written not in words, but in the silent, predictable motions of the heavens. What does it say about us that the same handful of stars could guide a Polynesian voyager across an ocean and tell a Greek farmer when to sow his seeds? The ingenuity of these ancient astronomers was matched only by the elegance of their tools. It all began with the simplest of instruments, the gnomon. This was nothing more than a vertical stick planted in the ground, yet its moving shadow traced a story written by the sun. By carefully marking the shadow's length at its shortest point each day, an observer could follow the sun's journey north and south. The day with the longest shadow marked the winter solstice, the shortest shadow the summer solstice. This humble stick was a complete solar calendar, a clock, and a scientific instrument, all in one. But for greater precision, more specialized tools were required. In the clear desert nights of Egypt, priests used a device called a merkit. This was a palm rib with a slit cut in it, used as a sighting tool. By lining up the merkit with a specific star, they could achieve the breathtaking alignments we see in the pyramids, ensuring their monuments were perfectly anchored to the cosmos. To track the passage of time after sunset, they turned to the clepsydra, or water clock. This was a container from which water dripped at a steady rate. Marks on the inside measured the hours, turning the relentless flow of water into a measurable, observable night. Yet all of these devices were leading up to a discovery, so advanced it seems to defy its own time. In the first year of the 20th century, sponge divers off the coast of the Greek island of Antikythera found the wreck of a Roman cargo ship. Among the statues and pottery, they recovered a lump of corroded bronze and wood that seemed utterly unremarkable. It was only years later, when archaeologists examined it, that the lump broke apart to reveal the remains of a complex machine, a labyrinth of interlocking bronze gears. This was the Antikythera mechanism, dated to the 2nd century before the Common Era. It is the world's first known analog computer. X-ray and CT scans have revealed a device of staggering complexity. Dozens of finely cut gears worked together to model the irregular motions of the heavens. By turning a hand crank on the side, a user could calculate the future positions of the sun, the moon, and the 5 known planets. It could predict lunar and solar eclipses, and one of its dials even tracked the 4-year cycle of the Olympic Games. This was not a tool for simple alignment or timekeeping. It was a portable, mechanical simulation of the entire known universe, a cosmos in a box. The existence of the Antikythera mechanism shatters the modern myth of linear progress. Here was a level of mechanical engineering and astronomical understanding that would not be seen again until the great clockwork planetariums of 18th century Europe. Its intricate differential gearing, a technology once thought to have been invented in the 16th century, proves that the ancient Greek synthesis of geometry and observation had reached a mechanical zenith. This single device collapses the timeline of technological history, forcing us to ask a haunting question. How much of this profound knowledge was lost in the fires of burning libraries and the slow collapse of empires? The Antikythera mechanism stands as a ghost from a future that never was, a brilliant glimpse of a path not taken, reminding us that our ancestors' intellectual journey was filled with peaks of genius whose heights we are only now rediscovering. This dual role of scientist and priest was the cornerstone of early civilization. The person who could read the stars held the ultimate authority, for they decoded the very language of the gods. In Babylon, the letter 1e6 dups hachek enuma anu enlil, the scribe of the celestial omen series, was a powerful court official. His readings of the sky directly influenced state decisions, from when to go to war to whether the king should undertake a long journey. A single eclipse, correctly interpreted by him, could postpone a military campaign or mandate a ritual of atonement to avert divine wrath. His knowledge was not public property. It was a closely guarded secret, recorded on cuneiform tablets stored in royal libraries, accessible only to the initiated elite. This secrecy was a source of power, but also a profound responsibility. The fate of the entire kingdom could rest on his accurate observation and interpretation. We see a similar, though distinct, dynamic in the Americas. The Maya Ajor, or Lord, was not just a political ruler but a cosmic one. His very blood was considered a sacred substance capable of communicating with the gods and maintaining the balance of the world. The astronomical observations conducted by his court were not abstract science. They were a form of celestial diplomacy. By performing a bloodletting ritual at the precise moment a planet like Venus reached a certain station, the king was actively feeding the gods and ensuring the sun would rise, the rains would come, and the cosmic cycle would continue. His ability to schedule these rituals correctly, based on the complex calendar calculations of his scribes, was the foundation of his legitimacy. The knowledge itself was so sacred and complex that it was a form of divine power, a direct line to the machinery of the universe. How different this is from our modern view of a scientist in a lab coat. For the ancients, to study the planets was to commune with deities. To calculate an eclipse was not to demonstrate intellectual superiority, but to participate in a divine drama, to help the moon in its battle against darkness. The priest astronomer stood at the precipice between the known world and the overwhelming mystery beyond, translating the silent motions of the heavens into a blueprint for human survival. This sacred trust, however, would eventually face a challenge that could not be answered by ritual alone. That celestial calendar did not remain locked away in a priest's scroll or a king's decree. Its daily, tangible power reached every single person, from the humblest farmer to the mightiest pharaoh. For the farmer, the movements of the stars and the sun were not abstract ideas. They were the ultimate instruction manual for survival. The heliacal rising of the Pleiades might signal the moment to prepare the dry soil. The summer solstice meant the grain was nearly ready for harvest. The autumn equinox was a final, urgent call to gather the last of the crops before the cold set in. His entire year, his family's livelihood, was a direct response to these celestial cues. His life was a conversation with the sky. This knowledge was shared through community rituals, through songs sung at planting time and harvest festivals that everyone understood and celebrated. The sky gave the rhythm and the people danced to it. For the builder and the architect, this cosmic order was a design principle. It was not enough for a temple to be beautiful or strong. It had to be cosmically correct. A house, even a commoner's dwelling, might be oriented to face the rising sun, welcoming its life-giving light and warmth each morning. A city's main street could be aligned with the solstice sunrise, turning the entire community into a living monument to the sun's power. For the pharaoh or emperor, this connection was the very source of their authority. A successfully predicted eclipse was not just a scientific triumph, it was a public demonstration of their divine mandate. It proved they maintained the crucial relationship with the gods that kept the world in balance. When the people saw the moon darken exactly when the royal astronomers said it would, it reinforced the entire social order. The king's power was written in the stars, and his ability to read that script justified his rule to every farmer, every builder, every citizen in the land. The sky was the ultimate clock, calendar, and constitution, all rolled into one. Its silent, predictable motions dictated when to work, when to worship, when to build, and who to obey, weaving the cosmos into the very fabric of daily existence for an entire civilization. The grand clockwork of Greek astronomy fell silent in Europe. With the Roman Empire's collapse, the intricate state support for science and scholarship crumbled into 1,000 fractured kingdoms. The complex planetary models of Ptolemy, the radical ideas of Aristarchus, and the precise observations of generations were no longer copied or taught. The great libraries grew quiet, their precious texts crumbling into dust or lost to fire and neglect. In this new world, survival was a more pressing concern than the motion of Mars. The sophisticated cosmos of interlocking spheres was replaced by a simpler, more mythologized universe, a flat Earth under a dome of fixed stars, where celestial events were seen as direct miracles or divine warnings rather than predictable phenomena. For centuries, the flame of systematic cosmic inquiry in the West flickered, threatening to go out entirely, but a flame can be carried. While Europe endured its so-called Dark Ages, a brilliant intellectual renaissance was flourishing far to the east, in the capital of the Islamic Abbasid Caliphate. Baghdad's House of Wisdom became the new center of the astronomical world. Here, caliphs sponsored a massive translation movement, gathering scholars from across the known world to render the entire corpus of Greek science, including Ptolemy's monumental Almagest, into Arabic. But these scholars were not mere librarians. They became brilliant refiners and innovators. Figures like al-Battani dramatically improved the measurements of the solar year and the precession of the equinoxes. Ibn al-Shatir developed planetary models that mathematically eliminated the need for Ptolemy's clunky equant point, creating a system that was strikingly similar to the one Copernicus would propose much later. In observatories from Damascus to Samarkand, they built giant quadrants and armillary spheres far more precise than anything the Greeks had possessed, compiling star catalogues of breathtaking accuracy. This was not a dark age, it was a golden one, just in a different part of the world. The intricate knowledge of the ancients was not lost. It was being preserved, translated, corrected, and advanced, safeguarded in the great libraries of the Islamic world. This preserved torch of learning would wait for centuries until political shifts, trade routes, and the fall of Constantinople would finally push these texts back into Europe, landing in the hands of a new generation of thinkers who were ready to question everything. The stage was being set for a revolution, all because a flame kept burning in the desert was about to be carried back home. The scattered stones we once dismissed as primitive altars now hum with a silent, precise intelligence. This re-evaluation is the work of a modern scientific detective, a field known as Archaeoastronomy. By merging the trowel of the archaeologist with the sophisticated software of the astronomer, this discipline has breathed new life into ancient ruins. It allows us to stand where a priest astronomer stood thousands of years ago, to look through that same roof box at Newgrange and calculate whether the solstice sun would indeed pierce the darkness. We can input the precise latitude of Chankillo and the exact positions of its 13 towers into a computer model, running the sun's path back through millennia to confirm its function as a solar calendar. This is not guesswork, it is a rigorous test, and for so many of these sites the results are unequivocal. The alignments are too perfect, too repeated to be accidental. What does this proven precision force us to confront? It shatters the old, comfortable narrative of the primitive savage. The builders of Göbekli Tepe were not simple hunter-gatherers huddled around a fire in fear of the dark. They were the intellectual rivals of any classical philosopher, employing a sophisticated understanding of geometry and cyclic time. Their laboratory was the horizon, their library the night sky, and their legacy is a language of alignments carved into the very bones of the earth. This stone tape recording of celestial knowledge challenges our deepest assumptions about the trajectory of human intellect, suggesting that the drive to measure, to predict, and to understand our place in the cosmos is a defining human trait, one that flourished in brilliance long before the written word. From that first aligned pillar at Göbekli Tepe to the intricate bronze gearwork of the Antikythera mechanism, our journey reveals a profound and unifying truth. The human impulse to understand the cosmos is not a modern invention, but a force as ancient as civilization itself. These first astronomers, scattered across every continent and separated by vast oceans, were the true pioneers of science. They had no telescopes, no satellites, no formal laboratories. Their tools were the horizon, a standing stone, a notched stick, and the limitless power of a questioning mind. They looked up at the very same stars we see today and saw a practical guide for survival, a divine script for kings, and a grand mathematical puzzle waiting to be solved. They used the sky to build accurate calendars that fed nations, to navigate terrifyingly open oceans and discover new worlds, to legitimize rulers and structure entire societies, and ultimately, to seek our species' deepest meaning within the vast, silent universe. Their legacy is not confined to the monumental ruins they left behind, those silent stone witnesses that still capture the sun's rays. It lives on in our own unbroken quest for knowledge. Every time a modern astronomer points a radio telescope at a distant galaxy, every time a physicist models the birth of the universe, they are walking a path first cleared by those ancient stargazers. So the next time you find yourself under a clear night sky, away from the city's glow, take a moment to simply look up. In that act of quiet observation, you are participating in a tradition that spans tens of thousands of years. You are connecting directly to the very first curious minds who dared to measure the heavens, and in doing so began the greatest story ever